and to have these instruments fit inside the rover or on the outside of the rover and have them integrated, it's a tremendous challenge that I think that NASA and the science team has really stepped up to.
Okay, we have time for a couple more questions, so let's get the mic over to, there you go.
Hi, Nadia Drake with Science News, and I'm wondering if we know how Mount Sharp formed and if there are any analogs on Earth.
It's a great question, and the science team is the question was if we know how Mount Sharp formed. The short answer is no. We'd like to address that. There's a number of hypotheses. Part of answering how it formed, and I presume by that you mean the shape that it has today. Yeah, is understanding how the layering formed in it, what materials the mound is made out of, and what they represent in terms of the mechanisms. I think that this is a feature that was recognized by Mike Malin and Ken Edgett going way back to probably the early days of mock observations, and they made an incredibly important observation, and that is that Gale is not alone. There's a family of craters that they sort of drew an evolutionary tree, and pointing out that these big Noachian craters that are 100, 150 kilometers in diameter are filled up. And then you can go and go a couple hundred kilometers away and see one that's partially eroded back, and it begins to get a little bit of a moat. And then you go in another direction, a couple hundred kilometers, and you see one that's more eroded back. And Gale seems to be the one that's at the evolutionary end of the spectrum that's the most eroded back. It's too high to be the central peak associated with the impact itself. We can see the layering from orbit that tells us that the material is not massive, it's not impact ejecta. It's hard to get around the case that it was once filled up, that crater was once filled up. These are always difficult stories to come to grips with scientifically. It becomes a story of ships that pass in the night. Everything's been eroded. Nobody was there to see it. How do you go about testing this hypothesis? And it's not going to be easy, but we're going to try.
Okay, I think we had a question in the row right in front. No, the orange, red, Carl. Maybe not. Does anybody have any additional questions? Okay, let's hop across the aisle to... Yeah, this is going to be the last question. Right there. Raise your hand higher, please. I will get you. Okay.
Yeah, hi.
Go
Conan
first.
Nolan, NBC Los Angeles. Dr. Meyer, you touched on this a moment ago, just very briefly, though. The public does remember Spirit and Opportunity. We remember Pathfinder. It's a much larger rover this time. The sense is that incrementally there's been advancement of our understanding of this planet. Is it your opinion that this could be more than just that the kind of instrumentation you have here, not just the imagery, is such that could lead to discoveries that far outweigh anything we've seen before on any of the rover missions prior to this one?
Well, there are two aspects. One is by having this instrumentation, we can confirm mineralogy that we think we see from space. So that can be huge in terms of just globally looking at Mars and going, oh, it's a different mineral than we thought. This means that the history is slightly different. The other thing, and part of the reason why I like to view this as the first astrobiology mission since Viking, is that we are going to measure organics on this roving laboratory. And one of the big pieces that we're missing for understanding habitability is we have the water. We think we have the water. We're going to confirm it with Curiosity. I think we have the energy sources, and we have to find some discontinuities, that sort of thing. But I think we're relatively confident that there are energy resources on Mars. But what's missing is we haven't seen the organics. And so one of the big measurements that Curiosity is going to make is finding, hopefully or not, finding organics. This is a big question. We have good theory that suggests that there should be very refractory organics still there on Mars available in many of the, not many, but some of the places that we look. But we don't know. We don't know the problem. We have this radiation environment on Mars that can destroy organics. So even if it was there, it may be hard to find a place where it's been preserved. But I think that measurement is going to be one of the key ones that will encourage us or discourage us in terms of what Mars was like early in its history or even today.
Can I add to that?
Yeah, please.
Let me just add to that a little bit. I think one of the things that will really distinguish this mission is, in addition to the larger size rover and the payload, which in one sense may seem incremental, the fact that it's really the science problem that we're addressing that is presented by the field area. This Mount Sharp that sticks up gives us this time dimension that has never been explored before. We did it a little bit with MER. All of us that worked on the Opportunity rover got really excited with a few meters of stratigraphy, a little tiny snapshot amongst billions of years of the history of Mars. When we went to home plate with the Spirit rover, we got another few meters. This time around, we have hundreds and thousands of meters. Every significant problem that has to do with the early evolution of the Earth, the interaction between life and environments that causes the tempo of evolution, that is exactly the way that we approach these problems, by taking hundreds and thousands of meters of stratigraphy as sort of a tape recorder of the way that the planet changes to understand what happened. That's what's really new about this mission.
Okay. Thank you. And we are unfortunately out of time for questions. If any reporters here still have questions, please check in with the newsroom, and we'll try to help you set up an interview or an opportunity to get your question answered. Okay, just a reminder that in less than 10 minutes we will be starting our mission overview engineering news briefing, 11 a.m. Pacific time, 2 p.m. Eastern time. And in the meantime, please stay tuned. We will be replaying all the visuals that you saw in the Science News Conference. And again, a reminder that lots of information is online on the mission, the Curiosity rover, online at www.nasa.gov/Mars. Thanks for joining us.
Very nice.